Hello everyone, and welcome to the first lesson in the Introduction to Algebra section. So in this video we're going to be talking about types of numbers. So what do we mean by types of numbers? Well, you might be familiar with, if I ask you to list some numbers, 1, 2, 3, 47, and so on. But in math we like to talk about the different types of numbers that we have. So the first type, or category of numbers that we like to talk about, is natural numbers. These are the numbers that I said count you would likely go for. So that's 1, and stop being yellow, 1, 2, 3, 4, and so on. Integers, on the other hand, are positive and negative counting numbers, and including 0. So -2, -1, 0, 1, 2, and continuing in both directions. Now, what do you notice about these two sets? By the way, these are known as the different sets of numbers. Well, we don't have any decimals, so where would something like 1.5 go? That's where rational numbers come in. So rational numbers are any number that can be expressed as a fraction using only integer numbers. So a fraction with integers. So in the case of 1/5, that's 3/2. Again, that we could still write that as 1/5. It doesn't have to be written as a fraction, but it can be written as a fraction with only integers. So 1.5, things like 2.73, -8.9, these are all considered rational numbers. So then what would be the flip side of that? Irrational numbers. Well, that would be if we have a fraction, but we can't write it with integers, or any number at all that can't be written in integers. This is something like a repeating decimal. So a lot of you are familiar with the concept of pi. That's equal to 3.141, and it just keeps continuing. This cannot be expressed with integers because it is a number, a decimal, that does not repeat. And it does not end. The same is also true for example, square root of 2. That does not repeat, and it does not end. So all of these together are what are known as real numbers. So if we draw a number line, and let's say we go from -infinity to +infinity, real numbers are anything that exists on this line. So for example, we can have 1, which is a natural number, and it's an integer. We can have -3, that's an integer. We can have 1.5, which is a rational number. We can have -√2, which is an irrational number. So all of these are real numbers because they exist on the number line. So we can explain all of these numbers using this kind of graph. So these are all going to be our real numbers. So on the right side here we have irrational numbers. And remember, these are things like square root of 2, non-repeating decimals. Okay, on this side, the largest portion that kind of encompasses all of the inner portions are the rational numbers. So these are things like 1/2, 7/3, things like that. Then we have the integers, positive or negative whole numbers, including 0, so -7, 0, 3. And on the inside here we have natural numbers, which are the numbers that if I told you, count 1, 2, 3, are the numbers you would count. So notice, all of the natural numbers are integers. All of the integers are rational numbers. and all of the rational numbers are real numbers. So we can see that as you go out from the in, they all encompass each other. So this is a good way to remember whether a number is an integer, or natural number, irrational number, or irrational number. It's an easy way to see a number can be more than one of the types, so it's easy to see how these are classified. So now let's try to go through a few practice problems. And whenever I put practice problems, I recommend pausing the video first and trying them on your own. Alright, so we need to identify these numbers as rational, irrational, integers, or natural numbers. Let's look at the first one, negative 18. Since it's not a non-repeating decimal, we know that it must be a rational number. Since it's a whole number, we know it must be an integer. But since it's negative, it cannot be a natural number. So that's where we stop for the first one. Alright, number 2, that one's also rational by the same definition as we used earlier. And it's also an integer because it's a whole number. And since it's a positive integer, we know it's also a natural number. Alright, great. Next is negative 6.8. The decimal terminates, meaning it stops, so it must be rational. But since it's not a whole number, that's where we stop. It's not an integer, and it can't be a natural number. 7/2. We also know that that decimal stops, so it's also a rational number. But since it is a decimal and not a whole number, we can't continue. What about square root of 5? Well, 5 isn't a perfect square number. That means we can't take the square root of it and get an integer, a whole number. So that means it must be an irrational. So that's an important thing to remember. If you ever have a square root of a number that isn't a perfect square, you will always get an irrational number.